Okay, this is the P4 paper from June 2023. It's question number 8, which is the last question on the paper. And as I scroll up and down, you can see that this is parametric equations. We're going to be both differentiating and integrating with parametrics. So let's have a read of the question. It says we've got this curve C here, which is given by t1 plus t plus 1 over t and t minus 1 over t. Gives me the information that t is greater than 0.7. I'll need that in a second. And it says the curve intersects with the x-axis at the point Q. Yeah, I can see the point Q there. And it says find the x-coordinate of Q. Right, there's a lot of difficult stuff in this question, but this isn't one of them. This is really straightforward. For part A then, for Q, that's going to be where it hits the x-axis, so y is going to be equal to 0. So y was t minus 1 over t is equal to 0. So I just need to solve that. I'm going to get t equals 1 over t, which in other words means that t squared is equal to 1. So t will be plus or minus 1, but we just said that t was greater than 0.7, so t is not minus 1. T is just going to be equal to 1 there because t is greater than 0.7, so t is equal to 1, and I wanted x. X, which was equal to t plus 1 over t, is equal to 1 plus 1 is equal to 2. So the x value there is equal to 2. So here, this is the value 2, 0, and here I'm just going to put, just to remind myself, for q is when t equals 1. I'm only doing that because I've done this question before, so I know that we'll need that a little bit later on. And then it says, for part B, the line L is a normal to the curve at point P, and given that t equals 2 at P. So this value here, for P, t is going to equal to 2, and as I say, I'm going to need that later, so just be aware of that. So if I want the equation of this line, L, if I want the equation of that line there, what I want is a point on the line and the gradient of the line. That's how I find the equation of a straight line. So in other words, I need the point on the line. That's going to be easy enough to do. We'll do that first, part B. So for line L, we know that t is equal to 2. T is equal to 2, so x is equal to t plus 1 over t. So that's 2 plus a half, 5 over 2, and we know y is equal to t minus 1 over t, so that's 2 minus a half, so that's 3, that's 3 over 2. So we know point P is just 5 over 2, 3 over 2. So now what I want is the gradient, and if I want the gradient, I need dy by dx, and I need dy by dx. So let's say this for dy by dx, because that will give me the gradient. I've got it parametrically, haven't I? So I've got x equals t plus 1 over t, or in other words, x equals t plus t to the minus 1. dx by dt is going to be differentiating that. So differentiating that 1, and then remember t to the minus 1, multiply by the power, take 1 off the power, is going to give me that. Now over here, just to save myself a bit of space, I'm going to do exactly the same thing with y. So I'm going to get t minus 1 over t, y equals t minus t to the minus 1. So dy by dt is going to be 1, and then the minus times a minus makes that plus t to the minus 2. So dy by dx is dy by dt times dt by dx. If you've done lots of these, this won't catch you out at all. So that's going to be dy by dt, which is 1 plus t to the minus 2. dt by dx is flipping that over then. So divided by 1 minus t to the minus 2. I'm doing that quite quickly, but anybody who's done any practice, that really shouldn't cause you an issue at all. And then we want the gradient, so for m, let's call it m, for m, dy by dx is going to be equal to putting t equals 2 in, remember. So it's 1 plus 2 to the minus 2 over 1 minus 2 to the minus 2. Stick that on the calculator. It comes out as being 3/5. So that's the gradient of the tangent. That would be, if we're looking at what we've got, that would be the gradient of that line. We've got the gradient of the normal. So we've got minus 1 over that. So if m is equal to 5/3 for the normal, m equals minus 1 over that, or in other words, minus 3/5. So if I now want to work out the equation of the line, the whole point about doing all the work we've done was to get to this stage. Y minus y1 is equal to mx minus x1. That's how we find any straight line. What I tend to do on these videos is just label everything that I've got at this stage, have it all in one place before I start subbing it in. X1 was 5/2 and y1 was 3/2. So I'm just subbing all that stuff in. So we get y minus y1, y minus 3/2 is equal to minus 3/5 x minus 5/2. Multiply everything to get rid of that fraction on the bottom. So I'm going to multiply, I'll tell you what, let's try and tidy it up and get rid of all of it in one go. So if I multiply by 10, I'm going to get 10y, I'm just wanting to get rid of all the fractions all in one go, minus 15 is equal to minus 6 x minus 5/2, which then means 10y minus 15 is minus 6x plus 15, and then we were trying to get it to, well, in fact, we'll just do one extra step here, 6x plus 10y minus 30 equals 0. That's because I multiplied by 10. I just want to get rid of my fractions. That now tidies up to 3x plus 5y minus 15 equals 0. So if you times it by 5, you'd have got rid of the, sorry, you wouldn't have had the, to divide by the last little bit there. Okay, so, yeah, that's okay for the first part because it did say we were trying to show that equation was equal to that. As I say, I've done this question before, so I knew what I was going to get with that bit. And then part D. So part D is to try and work out region R shaded in figure 2 below, bounded by the curve, the line, right. So what we mean for this last part is, what we're actually going to get is that this is now going to be rotated about the x-axis, and we're sort of going to get, if I drop that down there, we're sort of going to get this shape here rotated round, and what I've got to do is to try and find this volume of revolution of this thing is now rotated about the x-axis. And when I'm looking at this now, so this is a bit that I want to explain to you before we get going and doing it, I've basically got a cone in there. So for the cone, I can work out the volume of a cone by just doing a third pi r squared h. That's going to be h. We'll work out what all that is in a minute. But what I've also got then is this sort of top to my shape here. Looks like a little disc that's rotating round. And in order to do that, I'm going to have to do that by integrating under the curve between here and here. Or in other words, between t equals 2 and t equals 1. So that's why we had those values in from before here. Let's explain it to you. Well, let's explain it to the examiner. And while I'm explaining it to the examiner, I can explain this to you at the same time then. So for part D, I want to find the volume of revolution generated. So that's going to be volume equals the volume of the cone plus the volume of revolution, the top part. So the volume of the cone, that's okay. That's just going to be a third pi r squared h. but then the volume of the revolution is going to be the integral of pi y squared dx. Now I've got it as a parametric version, so it's going to be, again, just do it nice and slowly here, third pi r squared h plus the integral. This is going to be pi y squared, excuse me, handwriting, pi y squared dx dt dt, and I'm doing that between 1 and 2. Okay, so if I'm going to do those two bits, let's just work out the cone first of all. So for the cone, what have I got as my, let's go back to it. What have I got as my radius? My radius is going to be whatever that value there is. So that value there is going to be 3/2, and my height is going to be whatever that value there is. So it's going to be this minus that length there. Okay, so if I'm trying to work that out, then what's that value first of all? So that value I can get from this equation here. That value is just going to be when y equals 0 there. I'll show this all in a second, but if 3x plus 5y equals 15, when y equals 0, I'm going to get 3x equals 15, so I'm going to get that x equals 5. So I know that that value there is going to be 5. We already know what the value of the other one is. That's 5/2. So let's explain it to the examiner. So for the cone, plenty of time to do this one, so let's just take our time. For the cone, just go back and say what we're saying here. For the cone, L meets the x-axis. So for the cone, L meets x-axis. And say I've done it also, I'll just going to use the magic of the iPad to do this. Put that down and in there. We get that x is equal to 5. So third pi r squared h now is equal to a third pi 3/2 squared, lots of 5 minus 5/2. As I've done this question before, it works out to be 15 pi over 8. So I'm going to need to add that on now to my revolution. So volume of revolution now, because it still takes quite a bit of time. Long video this one's going to be. Volume of revolution. Okay, that was the cone. For the volume of revolution, I've got the integral between 2 and 1. And let's take the pi out. But I've got pi y squared dx, so that's going to be y was t minus 1/t squared. And dx by dt we've already got as well, was 1 minus t to the minus 2 dt. So still quite a bit of algebra involved in this one. I'll race through it as quickly as I can, but yeah, this is the last question of a P4 paper. Find that it's going to be really quite grueling in terms of what we've got to do here. So I'm going to do it fairly quickly. T minus 1/t all squared. You go away and do it if you want to. It's a minus b all squared. And a minus b all squared is a squared minus 2ab plus b squared. So that's going to give me, you can do it slowly, t squared minus 2 plus 1/t squared. That times by my 1 minus t to the minus 2 dt. Let's just multiply that all out then. That's going to give me pi between 2 and 1. As I say, I've done this already before, so I'll do it quite quickly. You can take your time. T squared minus 2 minus 1/t squared. Then multiplying that all by t to the minus 2 is going to give me 1 there. It's going to give me 2/t squared there, and it's going to give me 1 minus minus 1 over t to the 4 there. Gosh, right, okay, let's integrate that then. Well, let's just tidy it up before we do integrate it. So the integral between 2 and 1 of what have I got here? I've got t squared, I've got 3 lots of t to the minus 2 there. I've got constants combined to be minus 3 there, and minus t to the minus 4 there. dt. Okay, let's just integrate it now. So add 1 to the power, divide by the new power. For all of them, it's going to give me, so t cubed over 3. It's going to be 3t to the minus 1. It's going to be minus 3t, and it's going to be plus t to the minus 3 over 3. All between 2 and 1. So then subbing those values in now, we're going to get 2 going in, gives me 8 over 3 minus 3 over 2 minus 6 plus 1 over 24. Minus, and then 1 going in is going to give me a third minus 3 plus a third, oops, just handwriting, plus a third there. That all works out to be 13 pi over 24 if you've done it properly. So our actual volume that we wanted, the volume required then, was the 13 pi over 24 I've just done, plus the 15 pi over 8 from the first part, which all goes to make 29 pi over 12. Okay, what did they say with the answer? It would be lovely if they'd actually asked me to prove it was equal to that. No, it's absolutely crazy, isn't it? For 7 marks there, why would they not just say, show it's equal to 29 pi over 12, so that I know that when I've gone through all that work and all that really complicated algebra, we've actually ended up with the correct answer. But hey-ho, last question on a P4 paper. So yeah, quite complicated, but I hope that all makes sense to you.